We're going to start section 6.2 on page 268, and it's about the binomial distribution. So we're going to deal today with binomial random variables. So I'm going to try to give you an idea of what this is. So we have discrete probability distributions. Discrete probability distributions. So these are going to be probability distributions that have to do with discrete random variables. So there are many, but the most important ones are the binomial distribution and the Poisson distribution. And your book shows you how to deal with these two kinds of distributions. We are going to cover only the binomial distribution in this course. So let's say that you have a probability experiment. So we're going to start with a probability experiment. And your probability experiment has only two outcomes, two possible outcomes. So you either have a success or a failure. So that's the probability experiment. You do something, you ask a question, you get a yes or no answer, something like that. You only have two possibilities, two possible outcomes. So then, and also you know the probability of success in advance. So from previous research or from some theoretical work, you know the probability of success. So for this thing, on top of knowing, having a probability experiment, we're gonna know. So we know the probability of success in advance. And then what we're gonna do is we're gonna repeat the experiment many times. So anytime that you repeat the experiment, you get a success or you get a failure, but you're going to repeat the experiment. So these are the steps. One, or the second step, the first, the second one. The third thing is that we repeat the probability experiment. Many times. Each one is going to be known as a trial. So you're going to repeat the experiment many times, so you're going to have n trials at the end. N trials. Finally, you're going to count the number of successes. You're going to count the number of successes. So you were asking to people whether they believe in UFOs or not. So you count the yes responses. So, and that is going to be your random variable x, the number of successes, the number that the people responded yes to a question or something like that. So that's this kind of behavior, this kind of working with the binomial variable is going to be able to express by using an equation that is going to be known as the binomial distribution. So first, let's just summarize the conditions for the binomial distribution to exist. Those conditions are in your book on page 269, so you can read the conditions there, and I'm just copying those conditions in your notes. So the conditions are here. You need a fixed number of trials, n. Then there are going to be, remember, two possible outcomes for each trial. So a success or a failure. Then you know the probability of success, and it's always the same for each trial. And also another condition to have a binomial distribution is that we need the trials to be independent. So in other words, the outcome of one trial doesn't affect the outcomes of the other trials. So if you ask a question, do you believe in UFOs? The response of one person is not going to affect the response of other persons. So that's important to have the trial to be independent. You're going to ask the question maybe in a secluded setting. So maybe if you ask a question about believing in UFOs to a group of people, maybe the first one is going to influence the second one, and so on. So the best way to conduct the experiment then is you're going to take apart a person, you're going to call apart that person to ask the question, and then you're going to record your responses. So the trials should be independent. Finally, we're going to have the random variable capital X representing the number of successes that occur. So what are the variables? What are the values, the numerical values that we're going to have here? We're going to have the number of trials. It's going to be n, and then we're going to assign the variable p, lowercase p, for the probability of success. So on page 270, we're going to have the equation describing the probability distribution. So you can see the equation here on that page. So I'm going to increase the font size for a moment just for you to see the equation. So you can read here for a binomial random variable capital X that represents the number of successes in n trials with success probability p. The probability of obtaining X successes is going to be that one. So P of X is going to be equal to that symbol n capital C sub X times P to the X times 1 minus P to the n minus X. And the possible values of X are 0, 1, 2, 3, and up to the maximum value of trials, maximum number of trials. So that is going to be the formula that we're going to use. However, we don't need to deal with this formula. We're going to use technology. We're going to use R. R is going to compute that. We're going to use that formula for us. So if you are asking yourself what is the meaning of this constant here, n capital Cx, you can read this as n choose x. This is a formula that we use to find all the possible combinations of n trials in groups of x successes. And you're going to use a formula like this, where n and this exclamation mark is read as n factorial. So factorials are another kind of numbers in mathematics. So a factorial, for example, n factorial is going to be just the product of n times n minus 1, then n minus 2, and so on until you get 1. So for example, 6 factorial is going to be just 6 times 5 times 3 times, sorry, I forgot 4 times 4 times 3 times 2 times 1. So that is going to be 6 factorial. You can use R to find this factorial. You just write factorial, and in the parentheses you write the number that you want to note it's factorial. So that's the way that you use R. And also, if you want to get n choose x, you just use the formula, the command in R, choose n comma x, but we don't need that. We're going to use directly a formula to compute P of x, for a binomial distribution, or a binomial distribution. So the formula that I just showed you before, that the formula that is on page 270, this huge formula. So R has a command to get this formula used. So it's going to be the binom. Then you're going to enter the value of x. Then you're going to enter the value of n. So that is going to be called size in R with lowercase, and then you're going to enter the value of the probability of success, prob, and you're going to enter here the value of that probability. It should be given. So with this information, you're going to be able to get the probability of X given for a binomial distribution. So we're going to solve some problems to understand this. So we're going to start with example 6.14. So let me write this. So this is in R, how to compute a factorial, how to compute a combinatoric constant, or how to get the probability of binomial distribution. So we're going to start with example 6.14 on page 271. So let's see what that problem is. So we have this problem here. So let's read it. So it says that the Pew Research Center recently reported that approximately 30% of internet users in the United States use the image sharing website Pinterest. Suppose a simple random sample of 15 internet users is taken. So use the binomial probability distribution to find the following probability. So we're going to find the probability that exactly 4 of the sample people use Pinterest, then the probability that fewer than 3 of the people use Pinterest, then the probability that more than one person uses Pinterest, and finally the probability that the number of people who use Pinterest is between 1 and 4 inclusive. So let's start working on that problem. And let's see how we're going to use R to simplify our life. So we have first we have n equals 15. So there are 15 trials. So there were 15 people were interviewed. They were asked just the question, do you use Pinterest? Yes or no. So we know that the probability of success, P, is going to be 0.3 because the previous research shows that 30% of people use Pinterest. So the probability of success then is 0.3. So here you know the two outcomes. So the outcomes are 2 only. That's the reason we use the binomial distribution, because we have only 2 outcomes. So you either are a user or a non-user of Pinterest. So those are the 2 possible outcomes. Then what is going to be X? That random variable is going to be the number of people, who use Pinterest. So we need to use the binomial distribution, that equation that looks horrible. So NCX p to the x times 1 minus p to the n minus x. So, but that's just if you want to use the formula. So we're going to start then solving the first part. So the first part is we're going to find the probability. We're going to find the probability that exactly 4 of the sample people use Pinterest. Use Pinterest. So in other words, we want the probability when x equals 4. So you can use the formula I mentioned before, or we can use just R. So we're gonna use the binomial, and we're gonna set x equals 4. We're gonna say that the size, which is the number of trials, is just 15. Okay, it's here, and equals 15. That's what we call size in R, and in R we call prob, the probability of success that we in our book is p, lowercase p. So this is going to be 0.3. So that's the only thing that we need to enter into R to get the solution using this formula. So let's do that. So let's go and check here our console. So we're going to write here the binomial x equals 4, size, which is the number of trials, is 15, and the probability of success is 0.3. So we're gonna get 0.21. So that's the probability of x equals 4, that you can write just as p of 4. So that's the solution for part A. So let's continue with the next part. So we just write this. You can just write also p of 4 is going to be 0.2186 to 31. In your book, the solution is 0.2219. That's from the textbook. So they rounded off the number to 3 digits. So that's the first part of the problem. Now let's continue. The second part of the problem now is part B, and now we're gonna find the probability. Find the probability the fewer than 3 of the people use Pinterest. Of the people use Pinterest, fewer than 3. So you can write this as x less than 3, fewer than 3. So here, this is a compound event, so this is equivalent to finding the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2. Again, you can write in this way, or you can write just p of 0 plus p of 1 plus p of 2. So we're going to need to compute 3 probabilities. In R, you can write the binomial for the first one, for p of 0 is going to be just x equals 0, the size is 15, and the probability is 0.3, and then you're going to get the probability of 1. You're going to write exactly the same thing. So this is what you write for the second probability, and finally for the other one you're gonna write this: x equals 2, size equals 15, and probability of success 3, and then once you get those values you add them up. And also you can save some time, so all this work can be done in a single step. You can just write the binom, and then you're gonna write x, and you're gonna use the notation that we know for sequences. So x is gonna go from 0 through 2, and then the size is gonna be 15, and the probability of success is gonna be 0.3. So, but you're still gonna get 3 values. So let me show you. You're gonna get 3 values. You need to add up all those values, or we can use another extra step to simplify our work. So let's do this first and see what happens. So we're gonna go to our console. So we're gonna write the previous command is already there. I'm just gonna modify x that goes from 0 through 2. So I'm going to get 3 values. You can see 0.0047, 0.03, and 0.09. So the first one is for x equals 0, the second one for x equals 1, and the third one is going to be the value for x equals 2. So I'm just going to write those values in your notes, but we can just simplify our work a little bit more. So what we want is the sum of those 3 values. So what I'm going to do now is I'm going to enclose the entire command in parentheses. So the entire command is going to be enclosed in parentheses, and then I'm going to request the sum. So what I need is the sum. So the sum, if you use the sum of the entire thing, you're going to get 0.1268 to 77. So that is going to be the answer for this part. So again, you don't need to do a lot of typing. So here you have the 3 values, one for x equals to 0, x equals to 1, and x equals to 2. But what we want is the sum, so we're going to just write sum the binom x equals 0 through 2, size equals 15, and probability of success 0.3. And don't forget that you're going to close twice, and that's the answer. So your book has 0.027. That's the answer from the textbook. So what is this? This is just the probability of x less than 3. So now the third part. So now we have to find the probability. So we're going to find the probability. Find the probability that more than one person, that more than one person uses Pinterest. More than one person uses Pinterest. So so now what we want is the probability of x greater than 1, so more than one person. So this is going to be equal to the probability that 2 people use Pinterest plus the probability that 3 people use Pinterest plus the probability that 4 people use Pinterest, and so on until you get the probability that 15 people use Pinterest, because 15 is the total number of trials. So let's use just R to do this work. So we're gonna get first the probability for each of these values. So our x is gonna go from 2 through 15. The size is the same as before, 15. The probability of success is 0.3. But remember, this command is gonna give me 13 values or so. I need to add up all those values. So what I'm going to do is I'm going to enclose this into parentheses. I'm going to look for the sum. So let's do that using R, and then we're gonna get the answer. So let's see. Go back to R, and we're gonna use the previous command using the arrow pointing up. I'm just going to change the sequence. Now the sequence goes from 2 through 15, and that's it. It's going to be 0.96. So the probability of x greater than 1 is going to be 0.96, 47, 324. Your book is showing 0.965. That is the answer from your book. So that's the third part of the problem. So what are the other parts? Let's check. We have one more to finish this problem. So we are working, okay, the last part. So the next part is part D. We're going to find the probability, that the number of people who use Pinterest is between 1 and 4 inclusive. So what is that? So the probability that x is between 1 and 4, and that is just the probability of x equals 1 plus the probability of x equals 2 plus the probability of x equals 3 plus the probability of x equals 4. So we're going to use the same formula as before. We're going to sum all the probabilities by using the binomial distribution with x going from 1 through 4, and then we have the size again equals 15, and the probability of success equals 0.3, and we close twice because we are adding all the probabilities. So let's do that, and then I'm going to assign you some problems as class work. So okay, in R you just need to modify again the previous command. So we go back here, and we're gonna write now 1 through 4. 1 through 4. So this is gonna be the probability of x between 1 and 4 is just 0.51, 0.74, 35. So as you can see, working with the binomial distribution is not hard if you use language R. So your book for this problem has 0.511. That's the answer from the textbook. So now you're gonna solve several problems. We're gonna work on section 6.2, the exercise set. On page 277, you're gonna work problems 17 through 26. So work all those problems. So and then we're going to continue with the last part of this lecture. So I'm going to show you the problems 17 through 26. It's just playing with the binomial distribution. So in these problems, you're gonna have the number of trials are given. So in these exercises, 17 through 26, you're gonna determine the indicated probability for a binomial experiment with the given number of trials n and the given success probability p. And that's it. You're not going to find the mean, the variance, and the standard deviation yet. It's going to be the next part. So you're going to save these same problems for the last part of the lecture. So just try to get the probabilities that are indicated in those exercises. So remember n, you have to type size equals and the corresponding value of n, and then prob equals and the corresponding value of p. Take screenshots and you're gonna submit those screenshots later when we finish the lecture. Finally, as you remember, anytime that we have a probability distribution, we need sometimes to compute the mean and the standard deviation, the numerical summaries, because those numbers are very important to understand better the distribution. So the mean, the variance of a binomial distribution is going to be computed by using just the number of trials n and the probability of success. So the formulas are very simple to use. So you have here the mean, mu, uh, capital X is going to be just n times p. If you multiply these two numbers, you're going to get the mean for the binomial distribution. The variance, sigma square of x, is going to be just n times p times 1 minus p. So the probability, n times the probability of success times the probability of failure, because 1 minus p is the probability of failure. If you take a square root of this quantity, then you're going to get the standard deviation. So we're going to solve one more problem, and with that we're going to finish our lecture today. So here you have here the formulas that I just mentioned. They are going to be in your notes. So we're going to work now example 6.17. That example is on page 275. So this is the example that we're going to work now. 6.17. So we have that the probability that a new car of a certain model will require repairs during the warranty period is 0.15. A particular dealership sells 80 of such cars, so let capital X be the numbers that will require repairs during the warranty period. Find the mean and the standard deviation of X. So that's the problem that we're gonna solve to finish our lecture today. So I have here the problem. I just wrote the problem. So let's use the formula. So we need to identify first the number of trials is just 80 cars. That's the number of cars that the dealership sold. Then we have the probability that the car is gonna require repairs is just 0.15. Then we're gonna find the mean. The mean for this the mean of the distribution, the binomial distribution, is going to be n times p. So it's just 80 times 0.15. You use your calculator or you use R, and you're going to find 12. So you expect, remember, the mean is also the expected value. So that dealership should expect 12 cars to come back and require repair. So he might just adjust the auto shop or the number of employees to that quantity, to 12 cars. So that's the importance of using probability distribution, because you can plan in advance what you're gonna do in certain cases. So the variance, first we're gonna, the standard deviation, we can compute the standard deviation directly. So we're gonna take the square root of n times p, 1 minus p. So this is gonna be just 80 times 0.15, 1 minus 0.15, and you're gonna take the square root of this. And you can use R just to show you how to use the square root in R. So let's do that. We have time. So we're gonna write the square root of, and then we're gonna write the product. We have 80 times 0.15 times parenthesis 1 minus 0.15, which is 0.85, and we close twice because so the standard deviation is 3.193744. We're going to use those values later to learn how to do our predictions more with a probability. For example, 12 cars are going to be expected to come, but the 3.19 means that your value of 12 cars might be maybe 9 through 15, depending on the certainty that you want to have. So, but that is going to be covered on chapter 9 later. So you're going to work again the same exercises as before, 17 through 26, to compute now the mean and the standard deviation for the different cases that were provided. So remember, this exercise set is on page 277, and also I'm going to give you two more problems, 39 and 40. So those are the problems that you're going to solve and that you're going to submit using the corresponding assignment section on Canvas. So again, I'm going to give you the, if you want to check again the first problems, 17 through 26. This is the page. And then I'm going to give you time to copy this again. And then we need 39 and 40. Okay. 39 is here. It's about high blood pressure. So this is the kind of problems that you're going to find in your quizzes and in your exams. So you need to read carefully. You need to identify the number of trials. First, you need to identify the kind of distribution that you're going to need to use. Now you are learning about the binomial distribution. Later, we're going to use the normal distribution too. So you need to start learning how to distinguish one case from other cases. So in this case, remember, if you have two outcomes, then that's a binomial, a random variable. So you're going to need to use the binomial distribution. So that's problem 39. And problem 40 is here.